All right, so like I told you, the reaction is known as a free radical substitution reaction. Okay. So in a free radical so remember, main thing that you need to understand in like the topic of alkanes, okay? Alkanes do not, I told you alkanes are very, 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 very non-reactive, right? Like they don't take part in chemical reactions at all. And the reason for that is because they have a single covalent bond between the carbon atoms. Okay? Alkenes, on the other hand, are slightly more reactive, right? They're going to react better, but they will react more compared to alkanes because alkenes have a double covalent bond, right? And a double covalent bond basically allows you to add more molecules, more atoms. I can break the double covalent bond and I can use it to add more atoms to the molecule. If there is only a single covalent bond, so a single covalent bond is not easy to break. Hence, when we talk about a single covalent bond, so alkanes do not react easily. Alkanes will only react under one condition, and that is if there is a presence of UV light. And this is actually one of the tests, okay? One of the tests that you have between distinguishing between alkanes and distinguishing between alkenes, right? You react them with bromine. I'll explain that in a bit. But this entire free radical substitution reaction, what we're going to study today, we can actually use it as a test to distinguish, to figure out whether the chemical compounds in alkane or alkene. Okay, so in initiation, what is going to happen? Let's say that we have our chlorine molecule. Our chlorine molecule is Cl2. Our chlorine molecule in the presence of UV light is going to turn into chlorine free radicals. Now, I can explain this point to you slightly better. Okay, I'm going to explain this point to you. Okay?
Wait, so like
Yeah.
to like in a reaction, like right, to check if a compound is alkane or alkane, right?
Yeah,
You
alkane
need
or
to like
alkene, yeah.
you need to like shine UV light to check it.
No, no, no. I'll tell you what the test is. I'll tell you what the test is. I have not told you what the test is yet.
Okay.
I'll tell you what the test is. Don't worry. Okay. So this is the dot and cross diagram shows you the covalent bonding between a molecule of chlorine. Okay. Now, when I break this bond, okay, when I break this bond, there are two things that are possible. One thing that is possible is that one of the chlorine atom keeps both of the shared pair of electrons. Okay. One of the chlorine atom keeps both of the shared pair of electrons. So one chlorine atom will keep both of the shared pair of electrons like this. Right? The other chlorine atom is now has less electrons. So one chlorine atom kept both of the electrons, the shared pair of electrons. One chlorine atom kept both of those shared pair of electrons. Okay.
Wait, so isn't the other like
Yes.
the so
Yeah,
like
yeah,
there
go
are
on.
there are two chlorine atoms, right?
Yes. So
Yeah.
there
So
are two
like
chlorine. So
if
one is going to become negative ion and one is
oh,
going to
it's gonna
become
be
a
an
positive.
ion, right? Yeah, that's what I'm saying.
Yes,
I thought
exactly.
it's gonna be a free radical.
No, not yet. This is exactly what I'm explaining.
So when
Okay.
does an ion become a
Yes,
free radical then?
I'm telling you. This type of, so over here, this is bond breaking. Okay. One term that we use for breaking in your sciences is we use the term fission, nuclear fission, right? Nuclear fission, like we study in physics, is when you break down the nucleus to produce nuclear energy. So similarly, this is known as electrolytic fission. This is something I used to teach at A levels, but I know you grasp concept easily, and this will help clear the concept out much easier for you. Exactly what's a free radical is. You don't have to learn the terminologies. These are some things that I usually teach at A levels. Okay, but I just wanted you to have a clear concept, and since you usually pick up things quickly, so I was like, you'll understand this. This is heterolytic fission. Okay. In heterolytic fission, one of the atoms will take both of the electrons, like the shared pair of electrons, it will take both of them. So one of the atoms is going to become a negative ion and one of them will become a positive ion. Then there's another type of bond breaking. There is another way to break the bond. This other way to break the bond is in such a way that both of the chlorine atoms keep one of the shared pair of electrons. Okay. So each chlorine atom will say, listen, I will keep one of the electrons and you keep one of the electrons. So this chlorine keeps one of the electrons and this chlorine will also keep one of the electrons. Okay. Now, they are not, neither of these are an ion. Okay. Neither of these are an ion. Both of these have the same number of protons and the same number of electrons, right? This is why an atom is usually neutral, because an atom has the same number of electrons and same number of protons, right? In an ion, the number of electrons and protons are different. So in this particular case, the number of protons in chlorine are 17 and the number of electrons will also be 17, right? This is just the outer shell. So in this particular case, you can see that they are not ions, but they also do not have a complete outer shell, right? They do not have a complete outer shell, but at the same time, they're not a positive ion or a negative ion. This is known as a free radical. This is basically in essence what a free radical is. Okay, so whenever a bond breaks, for example, imagine this is in a covalent bond, right? Whenever a covalent bond breaks, for example, you have a bond between carbon monoxide, carbon and oxygen. Okay, if carbon becomes positive and oxygen becomes negative, that's just you are seeing heterolytic fission. The one of them is becoming positive, one of them is becoming negative. The second possibility, which is known as homolytic fission, the second possibility is that from the shared pair of electrons, both the atoms decide to keep one. Okay. So this way, what is going to happen that neither of them is actually going to become an ion. They're not going to become an ion because the number of protons and number of electrons are equal to each other. Right? But they still do not have a complete outer shell, which is going to make them reactive, which is actually going to make them highly reactive, right? That's why your ionic bonding and covalent bonding and all take place, because all atoms want to have a complete outer shell, right? So this is homolytic fission, and that is what happens over here. In free radical substitution, this is the type of bond breaking that takes place, right? Both of the chlorine atoms keep one of the electrons. From the shared pair of electrons, both of them are going to keep one of the electrons. So as a result, both of them have no charge. They're neutral. They don't have any charge. The number of protons are equal to number of electrons, but they are both highly reactive because they do not have a complete outer shell. Making sense?
Yeah.
So this is what a free radical is. Okay. Again, you don't have to learn these terminologies or whatever. That's fine. I just wanted you to understand exactly what a free radical is. Okay. So this is initiation. In initiation, I'm going to produce the free radical. Then step number 2 is propagation. What is propagation? Propagation is basically, think of it like a chain reaction. Okay. Over here, I have my methyl molecule. Okay. Not methyl, sorry, methyl. My methane, one of the chlorine radicals over here, free radicals, is going to attack my methane molecule. When it is going to attack my methane molecule, so again, this chlorine just wants to have a complete outer shell. That's it. That's all it wants. It's like, listen, my goal is simple. I just want to have a complete outer shell. I just want to make a bond with someone. So chlorine is going to see that methane is over here with 4 hydrogen. Chlorine is going to attack, and in the process, it will steal one of the electrons from methane, sorry, one of the hydrogen from methane for itself. Okay, it will take one, it will attack, it will take away one of the hydrogen atoms from methane for itself. It will take away one of the hydrogen atoms from methane. It's going to turn into hydrogen chloride, HCl. And now chlorine is content. Chlorine has made a covalent bond with hydrogen and now it has 8 electrons in the outer shell. Chlorine is happy. But now what has happened is that
HCl is gonna be hydrogen chloride or hydrochloric acid.
Hydrogen chloride.
Okay.
If HCl is in the form of a gas,
Oh yeah,
it's known
gas.
as hydrogen chloride. If it's aqueous, then it's hydrochloric acid. So over here, everything is gas. Chlorine is a gas, methane is a gas. So we get HCl in gas form as well. Now, what is going to happen is this. This is my methane molecule. Okay. This is the dotted cross diagram of methane. Now, what has happened? What has happened is this, that one of the hydrogen atoms has been stolen away by chlorine free radical. Okay. Now, what has happened is that this methane now has only 3 bonded pairs, right? It only has 3 bonds. 1, 2, 3. It still has the ability to make one more bond. It still has the ability to make one more bond. So now this is going to become a free radical. So think of it like a chain reaction. A free radical will attack a normal molecule. In the process, the free radical will become neutralized. It's going to become a normal molecule, but another free radical is produced. That's why it is known as propagation, because the reaction keeps on propagating and continuing. It doesn't stop, right? So chlorine was a free radical. It attacked the molecule of methane. It stole the hydrogen from it and made HCl. But now the problem is that methane now has one less bond. Carbon can have 4 bonds. But now over here, carbon only has 3. So this is going to turn into a free radical. This is known as a methyl. We call it a methyl free radical. Right? And this is propagation. So in propagation, the reactions continue happening, right? So now we have a problem. The problem is that we have a methyl free radical that wants to make one more bond. It's like, listen, I am just not happy right now. I have only 3 hydrogen atoms. I can make up to 4 bonds. One of my, again, you can see that carbon does not have a complete outer shell, right? So we have a free radical over here. So what is this methyl going to do? What is the free radical going to do? It is going to say, I'm going to attack another molecule of chlorine. There is a molecule, another molecule of chlorine. I'm going to attack. It is going to snatch chlorine. It is going to, methyl is going to snatch one of the chlorine atoms away. From the chlorine molecule, it's going to snatch. It's going to steal one of the chlorine atoms away. Like this. Okay, so this was the last bond. This was empty. So it's going to snatch one of the chlorine atoms away and it's going to make a bond with chlorine. Okay. As a result, now this chlorine is left behind as a free radical. Right? This is known as chloromethane. The way we name it is the way I taught you in the when I taught you the naming of the compounds, right? This is methane. First of all, meth, because it has 1 carbon atom. We write down ane because it is an alkane. and then chlorine becomes a side chain, okay? Because technically speaking, alkanes only have carbon and hydrogen. This particular case, we also have chlorine, but chlorine is counted as a side chain. So we write that down first. Chloromethane. And now we have a chlorine free radical, right? So what is going to happen? Now this chlorine free radical, the reaction number 1 starts again, right? The reaction starts all over again. This chlorine free radical is going to find another molecule of methane. Again, you will get hydrogen chloride and a methyl free radical. This methyl free radical will go find another molecule of chlorine. Again, you will get chloromethane and another free radical. And the reaction is going to keep on happening. This is known as propagation. Making sense?
Yeah.
Now, this reaction is going to keep on happening indefinitely. This reaction is going to keep on happening indefinitely unless termination happens. There is a criteria for termination. The criteria for termination is this. If any two free radical will react with each other, we will see termination.
So
If
termination only happens when two free radicals react with each
yes,
other.
exactly. If the reaction is between a free radical and a molecule, then the reaction will keep on happening. But if two free radicals decide to react with each other, then the reactions will terminate, right? In termination, what are the possibilities? Possibility number 1 is that two chlorine free radicals can react with each other and chlorine gas is made. Okay. Second possibility is that a chlorine free radical can attack a methyl free radical. Right? In this case, we will get chloromethane, CH3Cl. We will get chloromethane. Then, the third possibility that we can have is two methyl free radicals can attack each other. So, CH3 will make a bond with CH3. The result is that you will end up with ethane. Okay, this is known as termination, right? This is known as termination. This reaction is known as termination. So, a termination is only possible when two free radicals are going to react with each other, right? When two free radicals are going to react with each other, that is going to be known as termination. And in termination, these are the three possible reactions that we can see. So, in free radical substitution reaction, we are always going to first start off with initiation. In initiation, what is going to happen that with the help of UV light, okay? Now, let me also explain why we need UV light. The reason we need UV light is because UV light, because of the fact that, you remember I mentioned that
Wait, I think is it because
yeah,
because halogens are like non-reactive and only react with UV
yes,
radiation.
halogens are non-reactive, and because halogens are non-reactive, but again, the reactivity of halogen increases down the group. If you remember your topic of periodic table, you
Yeah.
must have studied that halogens become more reactive down the group. So chlorine is more reactive than fluorine, bromine is more reactive than chlorine. The main reason is this, because a single covalent bond is hard to break. That's the main reason. Okay? A single covalent bond is not easy to break. And especially if you want to make free radicals. Maybe you can break it to get a positive and a negative ion, but to get free radicals, to break the bond evenly, so that they both get the same number of electrons. That is why you need UV light. UV light is strong enough to break the bond and give you free radicals. Okay? After initiation, you will have propagation, in which the free radical is going to attack a molecule. And the reaction is going to keep on happening and happening and happening. Termination will happen only when two free radicals will join with each other, and these are the three possible reactions that we. So, I hope it's making sense now. What free radical substitution
Wait,
reactions are?
why do we need UV radiation? Is it
We
because
need
like
you,
to break the
yes,
single bond of an alkene?
to break the single covalent bond that exists between the chlorine atoms.
Wait, only UV radiation can break the thing.
To give us free radicals. See, we don't just want to break the bond and get positive ion or negative ion, right? We want free radicals. So in free radicals, what was the main thing? That the electrons were distributed equally. So to break the bond evenly, for that I need light. Okay, I can break it down into ions even as a part of chemical reactions, but I don't. I specifically want free radicals. Because I want free radicals, that is why I need UV light. Got it? Making sense?
So UV radiation is needed because to make free radicals.
Yes. Yes. To break the bond between the chlorine molecule and make the free radicals. Okay. So now this is making sense. Let me explain to you a really important concept. Okay. Look at the test that look at the reaction that I just explained to you with your alkanes. Okay. Now, alkenes can also react with chlorine. Okay, if I take an alkene, that can also react with a chlorine. And the reaction is going to look something like this. Let's say that I have.
So like the chemical reactions that alkane can do, right? So like
Yes,
alkanes can undergo two chemical reactions, which are like
yes,
combustion and substitution, right?
yes, that's it.
Well, what about alkene then?
Alkenes can undergo multiple reactions. So when I do, will after alkanes, we'll go over the chapter of alkenes. So I will go over all the reactions. Alkenes can do multiple reactions because alkenes have a double covalent bond. So they can take part in multiple reactions. You can convert them into alcohols. You can convert them back into alkanes. You can do quite a few things with alkenes. Okay. So for alkenes, we will study even more reactions, and the mechanism of the reaction is also slightly different, like for alkenes. Okay.
So
That,
the thing
yeah.
that we are learning right now is about alkenes, right?
And yeah, this is all about alkenes. Everything that I've taught you so far, this
Is
is about
alkane,
yes, alkane.
and
Exactly.
this is the thing in the box is alkene, right? But,
Alkenes, right?
but
I'm
what
teaching
is it
you
about?
the same reaction over here that we
Also
discussed for
substitution reaction, but then for alkenes.
yeah, not the substitution reaction with chlorine. Okay, that's what I'm telling you. So
Oh,
for
okay.
alkanes to react with chlorine, all of this needs to happen. You need UV light and all these things, right? So I'm
Same,
telling you
it goes for alkenes as well.
no, it does. For alkenes is different. Okay, and because for alkenes it is different. Okay, let me go over the reaction first. I'm not going over the reaction in detail. I'll teach you the reaction in detail when we do alkenes. But the reason I'm teaching you right now is because I can use the halogens to distinguish between an alkane and an alkene. Like I can use a halogen to tell if the compound is an alkane or alkene. And that point will make a bit more sense in like just a minute when I explain to you how alkenes react. Okay. So, for an alkane to react with chlorine, right, you need UV light. All of this free radical substitution, initiation, propagation, termination has to happen. Only then are you going to is an alkane going to react with an alkene. Now, for an alkene, if alkene wants to react with chlorine, the situation is quite simple. Okay. What is going to happen that between the two carbon atoms, we have a double covalent bond. Okay. This double, now don't worry about the mechanism and all. The mechanism is not important, right? What is the mechanism behind it? That mechanism is this mechanism you're expected to know in IGCSE, free radical substitution. Okay. This mechanism, how is it that the bond is breaking over here? This you are going to study when you do A-levels. Okay. So don't worry about the mechanism. Don't worry about how is the bond between chlorine breaking. Don't worry about that. That you're going to understand when you do your A-levels. the main thing you have to understand is this. In this case, what is going to happen? The bond between this double bond between carbon and carbon is going to break. Okay. So if I draw for you the dot cross diagram, it's going to look like this. Okay, so you can see that between the two carbon atoms, there are two shared pair of electrons. Okay, this is one pair and this is one pair. So you've got two shared pair of electrons between the two carbon atoms. That is exactly what a double bond means. Okay, now a double bond is easier to break than a single covalent bond. Again, don't worry about why. Why is it easier to break a double covalent bond? You'll again understand that when you do your A-levels. All you need to realize is that a double covalent bond is easier to break. So what is going to happen? That the bond between the one of the bonds between the two carbon atoms is going to break. Oops, I'm so sorry. I've done this incorrectly. Yes, now it's fine. One of the bonds is going to break. Okay. Now, one of the bonds is going to break, and now each carbon has got one free electron. Now, each carbon has got one free electron. Now, since they both have one free electron, that one free electron can easily make a covalent bond with the chlorine molecule. One chlorine molecule will come here, one chlorine molecule will come there. Okay? And this is what the final structure is going to look like. When I'm going to name the compound, I'm going to name the compound dichloroethane. Di because there are two chlorine, and ethane because this is a two carbon alkane. I started with an
Alkane.
ethane. Yes. The final product is an alkene. Can you see, Viraj? Look. We
But
started
you
with an
didn't you start with an alkene?
yes, we did exactly. That's what I told you. In organic chemistry, we can convert the compounds from one type to another. I can take an alkene and make an alcohol out, right? So what is happening that the main feature of the alkene is that between the carbon atoms, we have a double covalent bond. That's the main feature. If I'm going to break the double covalent bond, what is going to happen? That now all the bonds are single, right? If I break the double covalent bond, let me draw it like this. Look. Right? Now, if I'm going to break the double covalent bond, okay, I break the double covalent bond. Now, both of these carbon atoms have one free bond. They both have one free electron, so they can make a bond. We have two chlorine atoms. Each chlorine atom can come and make a bond with the carbon. There you go, right? The final product is an ethane. In the final product, it's an alkane. Do you see any single double covalent bonds in the final product? You
No.
do not, right? You only have single covalent bonds. That is an alkane. The side chains are chlorine. So you write down chloro. And there are two chlorine side chains. So we write down dichloroethane. So an alkene, so see, in a alkane, right? In an alkane, I have to substitute. Why? Because all the bonds are single covalent bonds, right? That's why we say alkanes are saturated hydrocarbons. Because all of the carbon can share four pair of electrons. All of the electrons are already taking part in making a bond. Or four of the carbon electrons are already involved in making a bond. That carbon has no space available. That carbon already has 4 single covalent bonds. The maximum number of bonds that the carbon atom can make are 4 single covalent bonds. That's it. Okay. This carbon atom already has 4 single covalent bonds. So if chlorine wants to become a part of the molecule, it will have to substitute. It will have to replace one of the hydrogen atoms. It will have to take the place of one of the hydrogen atoms, right? That is what has to happen. In alkenes, that's not true. In alkenes, because there is a double bond, so I can break one of those double bonds, and by breaking the double bond, I can create space. And then I can add those chlorine atoms into the molecule. With alkanes, that's why the reaction is substitution, because I have to replace, I have to substitute one of the hydrogen atoms for the halogen. With alkenes, I don't need to do that. With alkenes, the alkenes will react with chlorine at room temperature. They will react with the chlorine at room temperature. The reason for that is because alkenes have a double bond. I can break the double bond and it will create space. It will give the carbon atoms electrons, right? Free electrons that they can use to make a bond with chlorine. In this case, the chlorine atoms are being added. It is not substitution. The previous hydrogens are all still there. The previous carbons are all still there. Nothing has changed. I have just added the chlorine atoms to it. So alkenes undergo addition reactions. Okay, we use the term addition. Alkenes undergo addition reaction because they have a double covalent bond. So I can break the double covalent bond and I can make space to add more atoms to it. I don't need to replace, I don't need to remove any of the previous atoms. I can just add the chlorine atoms to it because a double bond was present. In an alkane, all the bonds are single covalent bond. Since all the bonds are single covalent bonds, there's nothing for me to break. A single covalent bond does not break easily. So I will have to replace, I will have to remove one of the other atoms and then I can place chlorine over there, right? So this is the difference between the reaction that we see with alkanes and the reaction we see with alkenes. With alkenes, we don't have to worry about anything. We put them in room temperature. I will put this with my halogen and they will react. Why? Because they have a double bond. The double bond is easy to break. Single covalent bond, no. Double covalent bond, yes. That because I can break the double covalent bond, so now each carbon is free to make a bond with the chlorine atoms. So the same chlorine atoms can be added. I don't need to substitute. I don't need to replace any other atom. I can directly add the chlorine to it. Not in alkanes. In alkanes, if I write down the overall equation, okay, oftentimes in the exam, they will ask you to write down the overall equation. This is your overall equation, okay, that we have methane. I am going to react my methane with chlorine. The final product is that I will get chloromethane and hydrogen chloride. So in this case, you can see that I had to replace one of the, this is the overall equation, right? Like the net equation. If I summarize the entire, I taught you the steps. If I summarize all the steps into one equation, this is the equation. Okay. Now, you can see I had to remove one of the hydrogen and put a chlorine over there to get the final product, right? I don't have to do that with alkanes. With alkanes, we can just add the, we can just go ahead and we can add the hydrogen, chlorine atoms over here. Making sense? What is the difference between alkanes and alkenes?
Yeah.
Viraj, making sense? What is the difference between like the reaction between alkanes and alkenes?
Yeah.
Same, yeah, same reaction. We're reacting both of them with chlorine, but an alkane, you need UV light. First thing. Second thing is that it's a substitution reaction. You will have to replace one of the hydrogens for the halogen. With alkenes, the reaction happens at room temperature. And when we talk about our reaction, so it's an addition reaction. I can just break the double bond and add 2 more atoms to the molecule. Now, on basis of this, we have a test. Okay, a test that helps in distinguishing between test for distinguishing between alkanes and alkenes. Meaning that I give you an unknown hydrocarbon. I say, Viraj, I do not know what this is. Can you please find out? How are you going to tell if it's an alkane or an alkene? React with bromine water. Bromine water is simply liquid bromine. Okay, if I take bromine and turn it like make a solution out of it, that's known as bromine water. Nothing fancy. Okay, at room temperature. Now, what is going to happen is this, that if we talk about our alkanes, okay, alkanes will not react. Alkanes will not react, right? Because alkanes will only react with halogens, or alkanes will only do substitution reaction when UV light is present. Right now, there is no UV light present. So, alkanes will not undergo any reaction whatsoever. The solution will remain orange. Bromine has, if you remember the topic of halogens, you must have studied that bromine has an orange, when you make a solution out of it, it has an orange color. So the solution will stay orange because bromine will stay as it is, the alkane will stay as it is, there will be no reaction whatsoever. But what happens when you take the same bromine but you add it to alkenes? Alkenes will react with the bromine. They will. Alkenes will react with the bromine because alkenes can react even at room temperature. Why? Because they have a double covalent bond. So I can break that double covalent bond and I can add the bromine to it.
So like
Alkenes
react the hydrocarbons with bromine water at room temperature, and like
yes,
alkanes will
exactly. Will
react,
not
not
react. So
react,
the
and like
solution will stay orange in color. Alkenes will react and the solution will turn from orange to colorless. Okay, the solution is going to change color. It's going to go from orange to colorless. Okay, why? Because alkenes will react with the bromine. They will react with the bromine, so the bromine is going to become a part of the molecule. You will get dibromomethane. But if you have an alkane will not react and the solution will stay orange in color. This is the test we use to distinguish between alkanes and alkenes. React with bromine water at room temperature. If the solution turns orange to colorless, you have an alkene. If the solution stays orange, you have an alkane. Okay, and the basis of the test, what is the principle behind the test, is what I just explained to you. All the reactions that you and I just went over, all the reactions that you and I just went over here, the free radical one and the addition one. That is the logic behind it, okay? At room temperature, the alkane will simply not react with the halogen. Okay, so the reaction will not take place. The alkene can react with the halogen and it will give you dibromomethane. So you will end up seeing that the solution will change color. Oftentimes you will see that in your textbooks, they will say that bromine water will decolorize. Decolorize means the same thing, that it is going to become colorless. Okay, so it's the same thing. So don't get confused. It means the same thing. It will become colorless. Okay, so this is how you can distinguish and find out if the compound is an alkane or an alkene. Clear? Any confusion?
no.
Perfect. So now this is what you have to know related to alkanes. Now let me open up a few questions for you so we can discuss them. Please just give me 2 minutes. All right, so the question says the table shows the displayed formula of some organic compounds. Explain why all of these compounds are described as hydrocarbons.
Because the only like two elements that these compounds contain are like hydrogen and carbon.
Correct. Okay. Okay, let me give you something, a new piece of information. Look at figure F. Okay. You'll see that in figure F, the compound is not in the form of a straight chain, not even branched. This is not a branched compound. It's not a straight chain compound. This is known as a cyclic compound. Okay, because all the carbon atoms are attached to each other. They're making like a they're making like a it's like a cycle. Okay, all of the carbon atoms are attached to each other. So far, I had always taught you about straight chain structures, or even when I taught you to make branches, they were all straight chain. There were always one carbon at the start and one carbon at the end. This is also another possibility. We call these cyclic structures. In cyclic structures, all of the carbon atoms are connected to each other. There is no terminal carbon atom. There is no carbon atom number 1, carbon atom number 4. They're all connected to each other. Okay? You're not going to be expected to name them, so don't worry about it.
Wait,
But
what are these type of things called?
cyclic, we call them cyclic structures or cyclic alkanes. Cyclic.
Wait, so like is it like related to like the displayed formula and like the molecular formula? So is it like a cyclic formula or something?
Yeah, it's like a type of another way of making an isomer. Okay. So you're not expected to know much about them. You're not expected to know how to draw them. You're not expected to name them. They don't expect you to know anything. Okay. But often in the questions, they will give you the structure. So I didn't want to be confused about what this is. This is an alkane. It is simply in the form of a cyclic structure. That's it. So this is an alkane. You are looking at an alkane, but this is simply in the form of a cyclic structure. It is just one of the ways of making an isomer. Okay. That's it. Okay, so why are B and described as unsaturated?
While B and E, because they have double bonds.
Yes, because they have a double covalent bond between the carbon atoms. You have to emphasize that the double covalent bond is between the carbon atoms. Okay, that's really important. Which letter represents the first member of the homologous series of alkanes?
A.
Yes. Which letter represents compounds that have the empirical formula CH2? Okay. Viraj, you must have studied about empirical
Yeah, we
formulas.
have done that.
Yeah, I know you must have. Do you remember them or do you want me to go over them again?
I think I know them.
Okay. Try this then. Then go ahead, give it a try. But if you can't, don't worry. I'll go over it with you. So you
Uh,
should know how to calculate empirical formula and then use the empirical formula to find the molecular formulas, right?
yeah.
Okay, so look, which letter represents the compounds that have the empirical formula CH2? Uh, Keep in mind that they're asking letters, so you need to give multiple options.
Yeah. To be honest, I don't know. Cause like I think I have to like calculate something, I think.
No, don't have to calculate anything. I'll tell you. Okay, this is good. Let me tell you exactly. Let me tell you. Do you know what is the difference between an empirical formula and a molecular formula?
Yeah, I think molecular formula like gives you like the real
Yeah, yeah.
like the
Okay, look,
real
I'll tell you.
formula and like a empirical formula like gives you like a imaginative.
Okay, now I'll tell you. A molecular formula tells you the actual number of different atoms or of each atom in a molecule, right? So for example, you have a formula that says, over here, let's take compound A, okay? So we have one carbon atom and four hydrogen atoms. This is a molecular form. Look at compound B. We have got three hydrogen atoms and we have got 1, 2, 3, 4, 5, 6, 6 hydrogen. In C, we've got three carbon, but 8 hydrogen. In D, we have got 4 carbon, but 10 hydrogen. In E, we have got 4 carbon, but we have got 8 hydrogen. In F, we have got 4 carbon and we have got 6 hydrogen. This is a molecular formula. A molecular formula will always tell you the exact number that these are the different atoms inside the molecule, and this is the number of each atom. So in each molecule, you can see how many carbon atoms and how many hydrogen atoms do we have. This is known as a molecular formula. So not only a molecular formula going to tell you what is the number, what is the different atoms inside a molecule, but what is also the total number of each atom. Okay, so total number of carbon, total number of hydrogen, oxygen, whatever. Then we have something, this is molecular formula. Then we have something we call empirical formula. Empirical formula is the simplest ratio between the number of atoms in a molecule. Okay, so for example, okay, for CH4, it's going to be CH4. We can't do anything. But take a look at C3H6. If I decide to use mathematics and take out the ratio, so 3 ratio 6, 3 ones are 3, 3 twos are 6. So we get CH2. That's the simplest ratio. The simplest empirical formula will tell you that for one carbon
Okay.
atom, we need 2 hydrogen atoms. Okay.
So C4H8 and then.
Yes. So over here we have C3H8. So again C3H8, I cannot simplify it any further, right? So C3H8 is how it's going to be. But in C4H10, again, my empirical formula can become CH2 because I can again simplify. For ones are 4. Actually, no, sorry.
You can't do
Not
that,
for,
yeah.
you can't do that.
It's
This
for
one,
CH4, C4H8.
yes, for that. 4 ones are 4 and 4 twos are 8, right? Then the last one, C4, and this is not 6, this is 8 actually, I think. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Again, we can have CH2. Okay, so this is like the empirical formula. It is telling you the simplest ratio, that the ratio between carbon and hydrogen is 1:2. A molecular formula will tell you the actual number of carbon atoms and hydrogen atoms in the compound. Okay, so over here, the correct options are B, E, and F. Okay, B, E, and F. C3H6, this is B. C4H8 and this C4H. All these three of them, we can take their molecular formula and we can simplify them further into CH2. So this is molecular formula and this is empirical formula. And now I hope it's clear. What is the difference between these two terms?
Yeah.
Okay, perfect. So whenever you're calculating the empirical formula, you're basically calculating the simplest ratio. That what is the simplest, smallest ratio between all the atoms in the molecule. that's what you're calculating. Now, our next question says, compound F has the same general formula as the alkene. Why does F not decolorize bromine water? If you go back to what I had just written, compound E was also C4H8. Compound F was also C4H8. Both of them have the same formula, right?
Oh,
F has
but
the
the
same
bonds.
Yes, go on. You're on the right track.
Wait, can you do the can you like bring up the question
Yes.
again?
Yes, same.
Compound F has a compound. Why does compound F? Oh, okay. Yeah, like can you go up again? Oh, F. Okay. So like since they have like the same formula, but like F, right, is an alkane because it doesn't have a double bond, and like
Yes,
alkanes
exactly.
are like.
Yes. That's it. That's all you have to say because F is an alkane, so it does not decolorize or it does not react with bromine water. That's it. That's all you have to say. So this is the main reason, okay? Because F is an alkane, right? That's the main reason. Perfect. Okay. Now they're saying one of the compositions of the compound in the table, one of the compounds in the table reacts with bromine to form G. Okay. A compound with the composition of mass, carbon 22%, hydrogen 3.7%, bromine 74.1%. Show by calculation that the empirical formula of G is C2H4Br. So we have to calculate the empirical formula. Okay. So the way we calculate, you probably remember this, but I'll just go over it with you, is like this. We'll write down the 3 atoms.
I know this.
After that, you know it, right? Perfect.
So I think like now we find the moles. So like we
Yes.
divide it by the, so carbon is
Yes.
12, hydrogen is 1, and I don't know what about bromine.
I'll I think
And then we'll
it's 79. It you can take it.
79, okay. Oh, 80, okay.
Yes,
We
it's
divided.
79.9. Yeah.
Okay.
Yeah,
We
yeah.
divided by the we get the answer, and then we divide it again by the smaller number,
Smallest number? Yes.
and then the ratio, and then we get the answer.
Perfect. So if you do that, this is what we're getting, right? 0.92. And then we divide all of them by the smallest number, so that's 0.92. So 1.85 divided by 0.92
So that's
gives
like
us
close to
2.
2, and then close to
Yes.
4, and then 1. So 2 for 1.
Yes.
So C2H4Br.
Perfect. Yes. So we get C2H4Br. Now, the relative formula mass of G is 206. Deduce the molecular formula of G.
Okay. I think so, yeah. 24 plus 4 plus 80, right? Now we get 108. Next answer we get 2. So if the molecular is 2, right? Oh, so it's gonna be C4H8Br2.
Yes, exactly. Good job. Perfect. So you calculate the empirical formula and divide it by the divide the molecular formula by the empirical formula, right? So the empirical formula comes out 108. Relative formula mass is 216, you get 2. So multiply all of it by 2, you get C4H8Br2. So now you can see that the empirical formula is the simplest ratio between all the atoms, while the molecular formula is the actual number of different atoms or each atom inside the molecule. Okay, perfect. All right, Viraj, we'll go ahead and we'll stop it over here for today. And then we will continue with questions on alkanes in the next class. All right?
Okay.